One final example of how to graph using delta math here, these rational equations. This is an example of one that will be a slant asymptote, and you know that immediately because the degree of the numerator is bigger than the degree of the denominator. So when we do our long division, why don't we just do that right now while we're looking at it. If we did it with the original equation, you'd have the x squared minus x minus 6 on the inside, 2x plus 4 on the outside. 2x times what would give you x squared would be 1/2 x. You'd multiply everything through. You would get the x squared plus 2x. You would subtract. When you subtract there, you get negative 3x. Bring down to negative 6. You would start again. 2x times what gives you negative 3x would be negative 3/2. That right there is going to be what our slant asymptote is. That's a little bit nasty, more difficult than any of the ones we would do. But what's nice, though, instead of doing that long division with the original problem, the x plus 2's cancel out. So we have an equation of x minus 3 over 2, which we can separate to be 1/2 x minus 3 over 2. Well, hey, guess what? Look at that. So it looks like our graph is actually going to be exactly like this slant asymptote, which is nice because delta math doesn't allow you to graph a slant asymptote. So there are no vertical asymptotes because the bottom equaling 0 never happens except for the part that's canceled. Remember, 2 can't equal 0. So no vertical asymptote, no horizontal asymptote. We're already off to a good start. X-intercept is when the numerator equals 0. So if I set the numerator equal to 0, the only part that's left to use is the x minus 3. So that means the x-intercept happens at x equals 3. The y-intercept is if I plug in 0, and again, it doesn't matter if I use the original or the new one for this, I get negative 6 over 4, which is negative 3 over 2, so negative 1/2. And the whole we said happened at x equals negative 3. Or I'm sorry, not negative 3, negative 2. That's when you have the cancellation here. Well, to find the y value for that whole, all you have to do is plug in y into the part that's left. So if I plug in negative 2 into that, I get negative 5 on top and 2 on the bottom. So when I plot my whole, it should be at an x value of negative 2 and a y value of negative 5 over 2. So that should mean, sorry about that, negative 5 over 2. So negative 2 comma negative 5 over 2. Now if you plot the rational function, it's going to plot that straight line and ends up coming up. Which the way we would have drawn that, we had our slant asymptote would have been at negative 3/2 and going up 1 over 2 every time. So you'd have a horizontal, or not a horizontal, but a slant asymptote that looked like this. We had our whole at this specific spot at 2 comma negative 5/2, and the 2 points that we knew already, which were again right on that horizontal asymptote. So basically we drew a line right on that slant asymptote just with the whole at that negative 2 comma negative 5/2. It does all that work for you, so you can submit your answer and get it right. And again, it's going to tell you exactly what you should be having and exactly how to find each step in the problem. Good luck.